Hello everyone, welcome to my new video. So today we are going to start a new topic, that is heap, and in this playlist we are going to solve questions related to heap. So there are many questions, there are various variations related to heap, and they are very important. So let's start with our first question. So the first question is, find the median of number stream. So the question says, like, for this one you have given two functions. One function is to add values and the another one in which you have to find the median. So let's talk about median. What is median? So if the size of the array is odd, suppose 1 2 3, so the middle value of the array is median. So in this case the median is 2. So suppose if the if the size of the array is even, so it's going to be the average of two middle numbers, that is 2 plus 3 by 2 is going to be 2.5. so this is the median. And what here? So add is like we are adding 1. So let's add from here. Like firstly we added 3, and now we need median up to this number. So one thing what we can do is we can maintain an array and we can sort it every time whenever we insert an element. So suppose in the first case it's going to look like this, but for the second step it's going to look like 1 and 3. For the third one it's going to be like 1 3 5, and for the fourth one it's going to be 1 3 4 5. So this is one way. This is we can say this is a brute force approach, but the complexity is going to be n square, and that is very bad. So we have to optimize this solution. So let's see how we can optimize this solution. So as you know, median is something that is present at the center. So suppose if this condition, if we can take this condition like 1 2 3 4 5, so median is something that is present at the center, and the elements that are on left side of the array are smaller than the median, and the elements that are present on right side of the array are greater than the element, right? So it means it look like we are dividing the question into two parts, right, from here. So for these kinds of questions we are going to use heap data structure. So let me explain you what's heap data structure. So heap data structure is a tree based data structure, and there are two types of heap that we are going to use. One is min heap and another one is max heap. So min heap, in which the parent value is always lower than the child. Max heap, in max heap the parent value have always been greater than their children. Let's take an example. So this one is my small heap, right? Because in this we are going to store small values smaller than the median. And this one is my large heap, because in this one we are going to store values that are larger than median. So here what we are here we are going to use max heap, and here we are going to use min heap. Now you guys are thinking, like, if this is a smaller heap, then why we are not using this min heap, and if this is a larger heap, then why we are not using max heap? So let me explain you. Suppose we have 1 2 and 3, and here we have 6 and 7 and 8. Just take an even condition. The size of the array is even. Now we have to find out, like, what's the median of this. So max heap always return the max value, so this will return 3, and min heap always return the minimum value, so this will return 6, and we just have to add and divide, and that's going to be our median. So that's why we are using this. So let's explore it more. So yeah, one more thing, like, their sizes are going to be approximately same. So why I said approximately, like, suppose if the size of the array is odd, what else we can do, right? So the max difference is going to be of 1, not more than that. So let's see the example we took. So this one. So this one, firstly we added 3. Suppose this is x is a median. I don't know what is a median, so this is our small heap in which I'm going to store this. I added 3 inside of this. Then and this is my large heap, which is going to be main heap. Now as of now it is null, so now I added 1. Now I pushed 1 inside, but wait a second, what happened here? Now the size of this one is 2 and this is 0, right? Now what we'll do, we'll took the max element, that is 3, and put it inside of this element 3. Now their sizes are same, right? Now if you want to find like what's the median at this point of time, then it is going to be, as this is an even number, it's going to be 3 plus 1 by 2, and that is 2. Now let's add another number, add 5. Now what I did, I added 5 here, and this is 3. Now they are approximately same, so that's not an issue. But issue is here is like, as you can see, the 5, the topmost, like the top element is greater than 3. How that can be possible, right? So if it's 1, 2 and 6, 7, right, element is not going to be greater than the top of this element. But here what's happening, 5 is greater than 3, so that's a wrong condition. So we have to push this 5 inside of this element. So if we have to find out like what's the median at this point of time, now the sizes of the heaps are not even, right? It's 1 and this is 2, so the whose size is greater than other heap, that's going to be the answer. So this size, the heap of min heap is greater than the max heap, so the top element of this is going to our answer, and that is 3. So this is our median. Now let's move to another point. Like if we add 4, so now I have added 4, 4, 1, I again pushed it into max heap, and this is 3 and 5. Yeah, looks fine to me, right? And now if we have to find out like what's the median at this point of time, then this is going to be top of this element plus top of this heap. This is also a heap. This is 3 divided by 2, and this is going to be 3.5. So yeah, this is the way we are going to find out like what's the median is going to be, and the complexity of inserting the element is going to be log of n. Insertion, similar for deletion, is going to be log of n. And if we want to peek on like what's the element on the top, then its complexity is of 1. Now let's talk about the solution. So this is my class, right? And I have made 2 priority queues. One is max heap and one is min heap. So this is my function where I'm adding numbers. So here I'm checking like, firstly I have added the value to the max heap here. Now I'm checking if the max heap is not empty and the min heap is not empty, and the first element of both the numbers. So for the max heap, if it's greater than min heap, then I have to push that top element from max heap to min heap and remove that element from the min heap. Here I'm checking if the size of the max heap is greater than min heap. So I'm pushing the top element of the max heap into min heap and removing the top element from the max heap. And similarly, I'm doing it for the min heap. If the size of the min heap is greater than the size of the max heap, then I'm adding top element of the min heap to the max heap and removing the top element from the min heap. If I have to find a median at a particular point, so if the size is even, right, if both the heaps are same, then we have to return their top elements and the average of their top elements. And if it's not, then I have to return the size. I have to return top element of the heap whose size is greater than the other heap. Yeah, that's all guys. Thank you so much for watching the video.